Have you ever pondered the immense challenges space explorers face as they venture into the unknown? Space, the final frontier, is a realm teeming with mysteries and obstacles that push the boundaries of human ingenuity. As we set our sights beyond our home planet, we are met with a universe of challenges. From the harsh, unforgiving environment of the cosmic wilderness to the myriad of technological hurdles that must be overcome, space exploration is far from a walk in the park. It's a test of our resolve, our creativity, and our ability to adapt to circumstances beyond our earthly experiences. Yet beyond the physical and technological, there's the human toll. The strain on the body and mind in an environment so alien to us is a challenge in and of itself, requiring a balance of physical endurance and mental fortitude. Today we delve into the top 5 greatest challenges that space exploration has presented. Let's journey together into the unknown and uncover the obstacles that stand between us and the stars. First on our list is the challenge of surviving the vacuum of space. It's an environment that's as fascinating as it is deadly, without air to breathe, temperatures that swing from searing heat to bone-chilling cold, and the constant threat of cosmic radiation. It's a place that humans are not naturally equipped to survive. But as we know, human ingenuity knows no bounds. To combat the lack of oxygen, we developed life support systems capable of providing breathable air for extended periods. To deal with the wild temperature swings, spacesuits and spacecraft are equipped with advanced thermal regulation systems. And to shield astronauts from the invisible but deadly cosmic radiation, spacecraft are fitted with specialized shielding and astronauts don protective suits. These solutions, while not perfect, have allowed us to venture into the vacuum of space and return safely. But the challenge remains. We must continue to innovate and improve if we are to truly conquer the final frontier. Indeed, the vacuum of space is not a friendly place for humans. The second challenge is the vast distances involved in space travel. Space, my friends, is not just big, it's enormous, it's gigantic, it's colossal. The distances we're talking about here are mind-boggling. To put things into perspective, even traveling at the speed of light, it would take us 4.25 years to reach the nearest star, Proxima Centauri. And that's just our closest neighbor in this cosmic neighborhood. Our current propulsion technologies like chemical rockets are like a horse and buggy trying to cross an ocean. They get the job done for moon missions and even jaunts to Mars, but for the long haul, they're simply not cut out for it. The time it takes to travel these astronomical distances is a major hurdle in our quest to explore the cosmos. That's where the bright minds in space technology come in, tirelessly researching faster methods of travel. Take ion drives, for instance. These futuristic engines use electric fields to accelerate ions, creating thrust. They're much more efficient than their chemical counterparts, but still, they're not quite Star Trekking material. Then there's nuclear propulsion, a concept that's been around since the dawn of the space age. This technology could potentially propel our spacecraft at incredible speeds, cutting travel times to distant destinations dramatically. However, it's still in the realm of science fiction for now. The vastness of space truly makes us appreciate the phrase, "distance matters." The third challenge we face is the human factor. It's not just about getting a spacecraft to the far reaches of the cosmos, but also about ensuring the well-being of the astronauts on board. This is a two-pronged issue, involving both the physiological and psychological aspects of long-term space travel. Firstly, we have to take into account the physical toll that extended periods in space can have on the human body. In the weightless environment of space, astronauts can suffer from muscle atrophy and bone density loss, a condition akin to osteoporosis here on Earth. Moreover, the high levels of radiation in space can lead to an increased risk of cancer and other serious health issues. These are not just theoretical concerns, they are very real problems that astronauts have faced and continue to face on their missions. But it's not just the body we need to worry about, it's also the mind. The isolation and confinement experienced during long space voyages can have significant psychological effects, including depression and anxiety. The constant stress of being in such a hostile environment, far from home, can take a heavy toll on an astronaut's mental health. However, there are extensive research and protocols in place to mitigate these effects. Astronauts undergo rigorous physical and psychological training before their missions, and scientists are constantly looking for new ways to protect them from the harsh realities of space. It's clear that space travel demands as much from the human body and mind as it does from our technology. The fourth challenge is the economic equation. Space exploration is a costly venture. We're talking about billions of dollars spent on the development and launching of spacecraft, not to mention the continuous investment required for the maintenance of space missions. It's like building a city in the middle of the desert, where every brick and every drop of water has to be brought in from afar. However, it's not all doom and gloom on the economic front. Enter private companies, the new players in the game of space exploration. Their involvement is making the enterprise more economically viable. These companies are injecting innovation and competition into the industry, driving down costs and opening up new possibilities. But even with these advancements, the economic aspect of space exploration remains a daunting challenge. It's a complex equation where we must balance the costs, risks, and potential benefits. The economics of space exploration is a puzzle we're still trying to solve. Our final challenge is dealing with the alien environments we encounter. You see, these environments are not just different from Earth. They're often hostile to our technologies and even to human life itself. Imagine trying to land a spacecraft on Mars. The red planet's atmosphere is far thinner than ours, making it difficult to slow down a spacecraft for a safe landing. NASA's ingenious solution? Sky cranes. These are basically rocket-powered hovercrafts that lower rovers onto the Martian surface. Now consider the Moon. Its surface is covered in a fine dust that's not only abrasive but also sticks to everything, causing all sorts of mechanical problems. To tackle this, researchers have developed dust-resistant materials and coatings. These examples highlight the sheer level of innovation and adaptability required to conquer the challenges posed by alien environments. And guess what? We humans are continually rising to the occasion, pushing the boundaries of what's possible. The alien environments we encounter in space continue to challenge our ingenuity and adaptability.